Welcome to the Databricks Skill Builder series. We're glad you're here.
So without further ado, thank you for joining the Databricks Skill Builder. These are sessions that we've had, on a weekly, bi-weekly basis to essentially, introduce customers or folks looking at learning a little bit more about Databricks and the different feature functionality that really helps really drive data and analytics and AI. So in this particular today, we're going to be talking about Delta Live tables. So before we get started, a little bit about myself. My name is Jesus Rodriguez. I've been Databricks SA for roughly a year now. I'm a father of three, been in pre-sales forever, so I feel like an old man. Born and raised in the Dominican Republic. Love my Databricks lab and environment and testing things out till they work. Like I'm sure a bunch of you guys are as well. And during weekends, I love orienteering, which is essentially running around through the woods with a compass and a map and finding my way through. Hopefully other folks are familiar with that. I do own chickens. If you see them there on the bottom right-hand side, they enjoy watching TV, apparently. They really do love it. Yeah, that's it for me. A couple administrative notes. If you have a question, make sure to use the Zoom button on the bottom, right on the bottom where it says Q&A, and Stephanie will help out as much as she can, and I'll do the same. I'll be monitoring them as well. Additionally, you guys are all on mute at this moment, so if you guys have a question, towards the end of the day, towards the end of the session, you can raise your hand and I'll unmute you, and we can talk through whatever questions you have. And finally, the session is being recorded and will be sent out later today or throughout the weekend, so that you guys can have the session review as needed, right? So to get started, I want you, before we get started, really take a look at this picture and imagine yourself being this I believe this infinity queue right here, sitting in traffic. Very, very messy, very, very frustrating. And imagine yourself having a stick shift during that session. When I first started driving, I had a 1991 Honda Civic that not only was it stick, but it was didn't have power steering or cruise control or anything like that. Contrast that experience with a more modern car, a more modern experience, like a car that has an automatic transmission and maybe has a those fancy adaptive cruise controls where you just set it and the car essentially accelerates and stops as needed. Something in the chat here. So the reason why I bring this up is this is very similar to what we deal with today on a daily basis. So imagine you're sitting in traffic, you have to press the clutch, you have to put it in first, you have to put it in second, you have to stop, you have to make sure that your lanes you're within the right lanes that you are driving in, unless you hit somebody else, or if you accelerate too fast, you're going to hit another car in front of you. That's really the experience that we see today within the data plane. This is our reality, our data traffic jam, where we have to maintain dependencies, we have to maintain data quality checks, we have to ensure that this particular table is going to another table and then it doesn't collide with anything else. Contrast that with, and this is really essentially how we're dealing with it today, right? When we start a data pipeline, we're looking at our data traffic jam, and all we really want to do is get from point A to point B. In this particular case, we just want to write a table, create a table that's from this JSON and concentrate on the transformations that are relevant to what the business wants, right? But in order to productionize it and get ready, you have to ensure that you understand the dependencies. Where is this table coming from? Where's it going to? How do you cleanse it? Optimize for performance with computations on the partitions on a daily basis or an hourly basis, depending on the scale of it. If there were a specific issue, you have to checkpoint and retry. You have to retry and you have to backfill your entire operation. Not only that, but there's multiple data quality checks that have to go on. Maybe the data changed from the last time you ran it, and downstream teams are having issues with the current data set. Governance, who owns this data? Where is this data coming from? Where's it going to? How do we backfill? The point is, it's simple enough to transform the data, but to go to production, it becomes more of a challenge. And there's a lot of ancillary, auxiliary processes that add burden to data teams to get to value, right? Contrast that with when we introduced Delta Live Tables. Delta Live Tables is essentially the autopilot, the automatic transmission, the adaptive cruise control for your data pipelines, where Delta Live Tables will essentially maintain and manage a lot of those ancillary processes that you have to keep, for example, from expectations from a data quality perspective. You can set these things throughout the stream. You can incrementally rebuild computations. The checkpointing, the retries are automatically handled for you. Because of the declarative fashion of the APIs, you essentially tell it where the data is coming from and where it's going to. And Delta Live Tables automatically will build out a DAG with all the dependencies related to it. You have the ability to do a full refresh or a partial refresh, all while collapsing into enterprise governance, enterprise CI/CD controls with your repos, and the ability to go outside the Databricks ecosystem by having an easy integration with Databricks workflows. And at this point, because all this stuff is handled for you, essentially by Delta Live Tables, you as a data engineer and a data team can essentially concentrate on just the transformations and click a button to productionize. So what Delta Live Tables bring to the table is accelerates your ETL development. I'll show you some examples of customers that improve their time to value like over 80%. It automatically manages your infrastructure and scales up and scales down as the data dictates. And not only that, we've actually added several improvements into our auto-scaling capabilities to better handle streaming scaling. As you guys are familiar with structured streaming is very easy to scale up. But scaling down, once the process has a hold of those, the compute is very hard to let go of it gracefully. So we've devised an enhanced auto-scaling capabilities built into the Delta Live Tables fashion. You have confidence in your data through our expectations API that essentially allows you to check or drop, count, or even fail your entire pipeline based on specific rules for data quality checks. And because it is based on Databricks and Spark, we have the ability to simplify your batching and streaming processes all in a single pipeline. So that if you remember their earlier diagram with your tables going this way and that way with your data traffic jam, this is how you get from raw data to compute to your business teams quickly and easily using Delta Live Tables. But now, how does it help? That's the underlying question, right? So a little bit about Databricks. I like to say that Databricks was built for data teams by data teams. So we understand the plight and the things that take away from that steal time away from your workflows. So as you guys know and are familiar with Databricks, we are constantly innovating. This is a timeline, just a rough overview of all the different feature and functionality that we've built into the platform to help data teams accelerate development and get to value faster. And more, so for example, ML Flow will facilitate the handoff of data to your machine learning models and manage that ML ops lifecycle. Delta Lake, as you guys are familiar with, is essentially the foundation of our lakehouse that brings ACID transactions to your data lake. And we'll fast forward over here to Delta Live Table, which is essentially the accelerator, the autopilot of ETL jobs. So how do we bring this automatic? How do we facilitate ETL for data teams more so than it already is, right? Most importantly, we believe, so for example, with the addition of a capability called autoloader, we have the ability to essentially maintain state and stream in data as it lands in your S3 buckets in your object storage. So essentially what that means is that you don't have to worry about any watermark patterns or looking for file dates when it was changed. This is all managed for you. And this is all developed by Databricks by by data teams for data teams. So it essentially automatically maintains track through a backend database called RocksDB that will keep the records that have been processed and only process the ones that have been that are new as of the last checkpoint. Additionally, it will keep track of your schema and give you the ability to evolve the schema with the data. So as the data changes, you have the ability to just add another column and maintain state on that schema so that it doesn't just fail the pipeline. We present and expose Delta Live tables through both SQL and Python APIs. These are the most popular languages that are leveraged for processing and manipulating data. This is great because you can actually switch between SQL and Python on the same pipeline, depending on the task at hand, right? DLT provides a declarative API that essentially you tell the API how to solve it. You abstract away the how and you define the what. So you don't have to essentially tell it what to do. It just does it for you. It automatically creates a lineage graph so you can, in a DAG fashion, so you can maintain and see the dependency flows of your data, and automatically checks for errors and missing dependencies through the syntax error before the pipeline is created. Additionally, we've actually built out a new API called Apply Changes Into that manages CDC change data capture on your behalf. Both SCD type 1 and SCD type 2 are currently supported. And this facilitates, you have your typical CDC logic that will take 20, 30 lines of code for you to manage the window functions and sorting. The Apply Changes Into, I've seen reduce not only the amount of code, but the complexity associated with developing a CDC pipeline. As mentioned before, there are data quality checks through the API called expectations. And essentially, expectations give you the ability to manage the integrity of your data throughout the entire pipeline. You can essentially see where, for example, within all your different steps, the pipeline or your data may have changed. And it gives you different actions you can take on top of the data, whether it be you can fail the entire pipeline if it's, for example, a mission critical and data can't be missing. You can drop rows. You can alert on specific changes, and you can even quarantine data through specific logic built into the pipeline. And all these metrics and events are captured in a system table that can be exposed through DB-SQL to monitor metrics, essentially give you additional observability to your pipelines. Any questions thus far? Cool. Yeah, I'm checking the chat. It says yes, it is the Tesla of data engineering. I was thinking about that, but I was afraid, with the bad press that Tesla is having recently, I'm just steer away from it.
We have a hand up if you want to mute him.
Okay, yeah, let's take a look here.
Yeah, hey, hi.
Hello.
Hello, this is Jasjot. So just wanted to understand this data quality check. This is very exciting, undoubtedly. I'm not sure if I'm audible.
Yeah, I can hear you. You're good.
Yeah, so this data quality check definitely looks exciting, but just wanted to understand, does it have the ability to execute, to check for, complex data quality rules, or maybe that is something that you have in your roadmap, in the coming months or maybe in the coming quarters. So
yeah, so essentially the data quality checks are anything that Spark can evaluate can be made through a data quality check. So we have very simple examples like, data is greater than, the integer greater than 0, it's not null, date before, date after. Those are relatively simple examples, but like within that table, you can do any Spark manipulation of the data and expose that through a column on your table that can then be exposed through an expectation. Does that make sense?
Yes, yes, absolutely. Thank you.
Yeah,
Thank you.
it was very flexible. So thank you for that. All right. Back to a regularly scheduled program. As I mentioned before, data pipeline observability. I feel that this is extremely important, not only on a per pipeline basis, to understand the events that are happening throughout the pipeline. There's an error, but also to gather metrics on the entire pipeline and or pipelines across the enterprise to see where the errors are happening, who's processing the most data, how long they're taking, and really aggregate metrics and get better at it, right? So these are all exposed through a delta table within your data lake or your delta lake. Then you can then go in, query, and expose, and there's a whole dictionary of tables and forms that you can go in and examine further. I see that there's a question I will allow to talk. Hey, Daniel. Daniel, I think your hand was up and you should be good. And if you can't, just go ahead and put it on the Q&A, and then we'll discuss it and wait till after the presentation.
We do have one question in Q&A. Do all the tables have to be Delta to be put in the Delta Life tables?
I believe the answer is yes, but I can double check that for you. We can read it in from any of those sources. You know, essentially anything that Spark can read into Delta Live tables, we can read it in. And I do believe that because of the capabilities around streaming and data checking and all that, they are by default written into Delta. But I'll check to see if there's like some sort of switch or flag that you can add to write to a different format. And if you may, Anil, could you add why you would want it in a non-Delta format? Is there like a specific reason? So from an automated, so we are data teams. Internally, we provide services to other data teams. And we see that continuous integration, continuous deployment paradigm shift is becoming more evident. With Delta Live tables, you're able to parameterize and essentially link it into your CI/CD process to manage all your jobs and pipelines through a repo, essentially, right? Not only that, but because of the flexibility allotted by Python, you're able to do and drive all your production tables through a metadata-driven process that can scale out as needed. And we'll touch up on that a little bit later during our demo. Additionally, you can do full refreshes of the data, or you could also do partial refreshes. So that, for example, if only one part of your pipeline failed, you can go in and do a partial refresh of your pipeline, and only the tables that were affected by the error will actually be rerun. And this helps tremendously, not only on finishing the job within a timely fashion, but using your compute resources effectively and elastically, that's the word, to lower the overall cost of your pipeline. And with automatic auto-scaling, the infrastructure will scale up and scale down as necessary, dictated by the amount of data that comes in. And again, because Databricks knows that we are not an island, we're partnering with several other parts of the organization. Through our workflow paradigm, we can orchestrate jobs that are not only within Databricks, but also outside by leveraging Apache Airflow, Azure Data Factory, or if you guys aren't familiar with multitask jobs, it's extremely powerful. Essentially, it's a multi-purpose orchestration tool that you can run DBT jobs, SQL, Python wheels, you name it, you can run it through our orchestration tool. And Delta pipelines, a DLT essentially bolts right into that process, so you don't have to change it too much. And this is actually really exciting as well. As I mentioned before, streaming jobs is extremely difficult. Not necessarily the scaling up, but the scaling down of these nodes. So typically the best practices has been for any streaming job that is required to do a static or a fixed size cluster so that you're not beholden to always scaling up. But we've actually improved significantly our auto-scaling capabilities with Spark structured streaming. And essentially with this enhanced auto-scaling, there is essentially our executors will have a view of the backlog from the streaming source before it comes through through the pipeline, and essentially will auto-scale up preemptively so that when that spike in events comes in, the Spark executors have scaled out to support the job. Additionally, just like that, if that spike in events goes down, the enhanced auto-scaling will reduce the number of nodes as needed to support the job. So this is really exciting. This is a great capability, in my opinion. And this is tried and true. It's been several customers that have been using it at scale and in production. I'd like to call your attention to Shell that's been using DLT to process 1.3 trillion rows of sensor data throughout the globe. And Audantic, and this is actually really my favorite part, and one of my favorite examples, because it essentially reduced the time to production by 86%. I mean, that's a significant improvement, because ultimately that's what we want to do. We don't want to sit here and develop jobs. We want to get the jobs done so they can get to production and get business value out of them, right? So 33% fewer lines of code, 86% reduction in time of product. And the industry, or excuse me, the enterprise essentially gained back $300,000 in productivity value, because the most expensive resource we have is not an EC2 instance, it's us, right? So we can do more with less time, the company wins. And without further ado, I'll flip over to my little demo here. Okay, so this is an example. Actually, here, let me go here. So a little setup for the demo. This is a little side project I've been working on, which is relevant to Apple Health Kit. I've been wanting to analyze my health data. There's so much data that goes into our Apple wearables or watch. It tracks our steps, it tracks our heart rate, our weight, you name it. It's being tracked by Apple, essentially. So HealthKit is a centralized repo for all your health and fitness data that's being generated from your iPhone, from your Apple Watch, and also any other app that you may give it permissions to expose through Apple HealthKit. And that's all managed within the Apple Cloud. But more specifically, I like the metrics that are being tracked. My VO2 max, which is relevant to overall aerobic fitness, heart rate zones. Like, for example, if you work out, like there's specific zones when your heart rate goes up, heart rate goes down that are relevant to what kind of fuel it's using, anaerobic, aerobic steps, and so many more. So this is a personal project of mine. And this is what we're going to be doing today. This is our data path. These are all the different apps that are generating data. On the left-hand side, this is all being exposed through Apple Health Kit. And Apple Health Kit I'm using a third-party app called Health Post, but there's a variety of different ways to export your health data from Health Kit, whether it be through an XML export or directly with the APIs. I'm using Health Post that essentially goes in and drops it into an S3 bucket. So this is great because my data is exposed in a JSON format in my S3 bucket, my cheap storage. I have Kafka here because there's an option. That's in the future development that I'll be doing, adding more streaming capabilities into it from a Kafka perspective. But right now we're dropping the data into an S3 bucket. But here's a challenge. You guys can see here, we have tons of small JSON files that are about half a meg. Each file has like 1,600 records, and they're all different. They all have different formats and scale. So How do we do this? There's over 10,000 files in my JSON bucket that account for about 4 gigs of data just for me. The data is riddled with quality issues. It has lots of duplicates, lots of nulls. There's varying data schema based on the type of data that's going in. So for example, there's sleep data, but sleep data will have a different relevant metric and format than our step data versus our heart rate data. And lastly, our records are dropped in intermittently by this third-party app. So we have to maintain state on which records were ingested, which ones were not. We don't want to reprocess the 4 gigs of data over and over again with Databricks. So what we do, we're going to call in our help from our friends with Delta Live Tables. And as I mentioned before, Delta Live Tables will help accelerate development, remove complexity, gives you all the different feature and functionality. So to start Databricks Delta Live Table pipeline, all you have to do is you have 2 options. One, you can leverage your SQL APIs, as I mentioned before. But in this case, we're going to be using our Python APIs. So with Python, and all you have to do is import the DLT library and call this decorator in front of any function that is going to process data. So in this case, we are using the view. And the view, it will load data, but we won't save it. It'll be like almost like if you're familiar with the SQL temporary view, that's essentially what we're doing here. So temporary view of our events as they come in. Any Spark function can be leveraged, and the return is what's going to be built out as your table or as your view. So in this case, we're going to be leveraging Autoloader. As I mentioned before, Autoloader will maintain state on the records that have been processed through our schema location, our checkpoint path. So essentially, our checkpoint path is what we call a RocksDB that keeps the schema of the data as it comes in, and also the last file that was processed. Additionally, we're going to be inferring our schema. The Autoloader will take in the first, I think, 10,000 files that are being processed, and will develop a struct that essentially maps to that data set. And obviously, as I mentioned before, we'll still give you the flexibility to evolve that schema by just either adding a new a new column to your table, or dropping it into what we call the rescue column, which will keep your data in its full fidelity in a separate column, so you can go back in and reintroduce it into the flow if it's relevant. There's a number of different parameters you can pass a Delta Live Table to essentially do different types of feature functionality for that processing. So for example, you see here, we're calling our Delta Live Table API. We're passing our name, which is, I want to call this specific table right to bronze. I'm going to set up a comment, blah, blah, blah. You can also pass specific Spark configurations to the pipeline, whether it be, for example, like, you want to trigger, if you're running a continuous pipeline, you want to trigger every 10 seconds when it pipes in. You can pass specific table properties, like you can optimize that table automatically. You can do Z order optimization as well. You can dictate the path where you want that specific table to be saved. With partition calls, you can partition the data as it lands, and you can define a schema or mention it, or drop it as a temporary table. So as I mentioned before, this is our Python API, and what we're going to be taking in this declarative fashion, we're going to be reading our landing view. So you see here, we're going to do a little bit of processing and return this table to our write to bronze function, and that gets written to DLT. So what this would look like, this specific pipeline, actually the last step here, is we're going to do data type association. So as I mentioned before, you have steps, you have sleep, you have heartbeat. You're going to have a lot of different data sets. this is just a tracker to see how many different data sets we're ingesting. And this is what that table would look like. Want to call your attention to a couple things before we dive into the actual data. Number one, you have a full record of all the steps and events that occurred during our table down here. And these are all the steps and events that are written to also to our Delta table that will maintain observability on all of our jobs. You can filter by info, warning, or errors, filter using text box. And we can go in and create, essentially pass different parameters to our pipeline as well. We can name our pipeline, we can run it as a triggered or continuous mode. Triggered essentially is you can write it on a cron job or as you trigger it. You can apply different cluster policies. If you're familiar with Databricks cluster policies, you'll be familiar with this process where you can essentially give it a specific instance type, specific access to data, specific customer groups that can access the data. It's all notebook driven. Give it different external, you can give it an external location or a schema to write to. You can specify enhanced autoscaling and photon acceleration. But wait, there's a little bit more that you can do here. There is a JSON file or JSON backend that essentially powers this, that makes it more programmatic and more software lifecycle development friendly. And in this particular case, I'm passing a couple of additional parameters, which will product edition is just the different feature sets that are available within the DLT pipeline. So real quick, I'm passing a specific Spark configuration that is going to give me access to a specific S3 bucket via the secrets API. So the secrets API, as you guys are familiar with, Databricks is essentially an obfuscation of API access keys and secret keys or passwords or environment variables, whatever you call it. This will be available to the secrets API. And this gives me access to the specific bucket that I want. You can define EC2 roles here. You can define, like I mentioned, cluster policies or ARN and all that. So I wanted to do that. And I press, so that's the settings page. You can also schedule it. Oh, oops. You go back. You can also schedule it as a cron job or run in a continuous mode, as mentioned before. You can set different permissions. And ultimately, you get a lot of metadata associated with your job. So we have our landing view, and you can see the specific schema that's associated with this landing view. It's essentially a mess of a nested struct in an array with like 30 different columns. And because of the evolution being tracked, we're able to maintain these columns as needed. And you can see where it's going. You can see some comments, and you can see that this is managed as a view. So more importantly, when we go to our right to bronze, this is our streaming table. And a streaming table is essentially a table that is an append-only job that will only take in new events from the previous step and append it to the bottom of our table. And you can see there's a little bit more metrics and metadata associated with this streaming table. For example, it's registered to our Metastore. The job took about 5 minutes, and we see the schema and the data quality in this particular case. And lastly, we have our data types. And this is where I wanted to call your attention to. So we pop into our metadata, our Metastore. So we can see exactly the data types that are being associated with our table. So we're going to be leveraging a specific field within our bronze that's called source type. And there's different source types. There's over, I think I counted 30 last time I saw it. And all these different source types are essentially have their own schema, their own view. And it's going to be going to be a bit of a hassle to migrate that over to our silver table. Oh, I apologize to the Amazon man. So this is our bronze table, and our bronze table, as I mentioned before, has several fields, and it's going to be it's going to be a bear to manage, right? This is what our data looks like. It's essentially a nested JSON struct with several different events, and it's going to be tough to manage. So for our next step, we're going to be leveraging metadata-driven framework to drive our tables for silver and essentially break out all different tables based on the specific our specific requirements. So this is what the metadata table looks like. I have it registered in a Metastore, and essentially what it'll do, it'll take the source name that you saw earlier, and we're gonna be passing specific columns, specific expectations of the data, and comments that will be registered to our Delta Live table, and this is gonna be the table name. So we'll take these 18 rows, and we're gonna be passing it through a loop. So essentially, we're gonna be reading it in. We're gonna turn it into a list so that we can loop through it and essentially pass all those metadata to this function that will do some basic transformations and also pass parameters. For example, here, we're going to pass the table name. We're going to pass the specific comment associated with that table. We're going to do expectations here. And also, we're going to pass columns that we want specifically to each data set. So for example, we see our sleep data. We'll have event sleep. It will have no expectations. But when we turn into our, maybe our exercise data, we want exercise minutes, and we want expectation of our exercise is greater than 0, right? So this is what an expectation would look like. So we take this metadata-driven approach, we run it, and our step will look something like this. So with those 3 cells in your notebook, you are able to build out all these different tables each with its own unique transformations and columns that are relevant to the workload. If we're going to zoom in a little bit more, we see that the metrics are being kept. And if you notice here, because it is a streaming table, our write to bronze was not reprocessed. Our write to bronze saw that there was no, since we ran it in the previous stage, it saw that there was no new events as of the last process. So we essentially checked it, skipped it, completed in 3 seconds versus the 5 minutes that were registered earlier then. If we look at our running, you notice that there's 1 record here and then 7 in this dropped records column. So we'll zoom out. Zoom out. Apologize for that. The GUI is funky right now. So we'll zoom out, and there we go. Whoa, that's why. Apologize for that. I kind of messed up my, there we go. So we'll zoom out and we'll see the additional metadata associated with it. So in this particular case, we've registered our table. We didn't drop anything. And then we see the schema that's associated with that data. All right. So now we have some silver tables. So now to do some expectations. So in this particular case, we're going to be running our silver and gold. We're going to be exposing our gold tables, and the expectations really presents 3 different options to actions that you can take on your pipeline based on the expectations. So for example, with our expectations, you have the ability to do an expect. So when you present a DLT expect, essentially what it does is maintains a record that will keep track of it in the system table that I mentioned before, where all the metrics and observability is available, but it will not take any action on the pipeline. So this is extremely useful if you wanted to just check data quality, but not fail or drop the records. There's also DLT expect or fail. And essentially what DLT expect or fail will do is if a specific record or violation is not met, it will fail the pipeline. So this is when maybe this table is presented to the CEO or a critical business function. This will stop, it'll still process the pipeline, but that specific table will fail. And because that specific table failed, the entire pipeline will fail, and you'll get a notification and you go in and examine it. And the benefit of that is that the downstream teams will not be affected by faulty data or unclean data. And the third option is expect or drop. And essentially what this means is if the parameter is true, drop that record and keep track of it, but it'll still process the rest of the records. And as I mentioned before, it's literally just a decorator that you would put before your function. And in this case, we are looking for start time is valid. So this specific field or column within our data set is not null. Very simple, right? So this will drop the records. If we move on, we have others that are more exposed here. So in this particular case, we're going to fail our data set if it doesn't meet the particular expectations. So when you see expect or fail, we're looking for a minimum heart rate of 70, and it's before this date. So what this pipeline will look like is essentially like this. So you see that essentially all the other events were processed, but if you go up to our expect fail, the data did not go through. And you see that from an observability perspective, the pipeline has failed outright. And then at this point, you have the ability and the option to select a table that you want to reprocess and let it go through as needed once you fix the issue. So hopefully this was a interesting view of Delta Lab tables, and you can see where it would bring a Tesla-esque autopilot option to your data pipeline. Now we can open it up for questions if you guys would like.
Don't be shy, just raise your hand.
Apologize for the zooming incident, by the way.
You're fired for zooming. Well, thanks so much. This was really great. It was a great presentation. Appreciate you doing it. I hope everybody has a great weekend.
All right, thank you, everybody. Bye.